Yes, in the previous session, we discussed how do we standardize x variables. How we uh, how we convert x variable to z score. Z means standardization, and we will focus on uh, this standardization of the normal distribution, right? Distribution. Here, you know that this is normal, right? Before standardize, this x random variable x distributed, normally distributed with mean and variance. Once we standardize, this x becomes z, is normally distributed, and the mean equals 0 with the standard deviation 1. Right? So that's the idea behind this. So that is illustrated here. So this is x value. Here we can see x value, and this is here. This line is a converted value, z score. So that's the idea behind this. And now you have to remember, this is the golden rule. This is a formula to standardize any x variable into z variable. Here, universal language, the standardization, the set score. The set score will apply to any scenarios that follows normal distribution. It's mean yes, normal distribution. Normal distribution mean mean, median, mode equal to 0. Here, x value minus the mean. This is average or mean. This is standard deviation. For example, here x value say 15, population mean so 20, yes 12, right? 12, and standard deviation equal 2. Then when we convert this x value into z, so what could be the z value of the z? It's straightforward. What's the x value here? 15. What's the mean? Average is 12, and the standard deviation 2. So z equal 15 minus 12 is 3 over 2. So z equal 1 minus 3. 1.5. 1.5. This is z. So x value 15 become z value equal 15. So in the raw data, this is raw data. In the raw data, you can see x values. Here in the mean, right here, this is the mean. No, so mean here the mean is 12. So we can see, we can locate mean here 12, and the z, so x, how much z? 15. 15 somewhere here. 15 is somewhere here. And now if we convert this value into z, this mean becomes 0, and this x value become what's 1.5. 1.5. And also remember the probability. So if anybody asks what is the probability of between 12 and 15, this area under the curve, no? Area under the curve is the probability. Now we can find the probability of this area by using the above formula, right? This formula, but it's take time. So therefore, we find the shortcut. It's the way, right? Already people found the area under the curve, and they have prepared a table. The table is called normal distribution table. Here, standard normal distribution table. You can look at here the term standard, and you this is a normal curve, and this is start from 0 and z, and the graph shows the area in the table. This shaded area we can find. For example, if z is 1.5, here z value we can look at 1.5 here, and 0, 0, 1.50 for this value. Yeah, area under this curve, area of this area is 0.4332. This area, right? You can get the same answer if you apply the above formula for this distribution table. And even though if you apply, if you find the area under this curve with the mean of 12 and the x value 15 and the standard deviation 2, we can find the same area, right, as given in this table. So if you have time, we can verify that. We can practice here on. Right. Now this is how we convert any x value into standard value set. Here now this 12 becomes 0, so and x become 1.5 now. So this is standard. This is normal distribution with raw data. This is standardized. Here we can see z values. Here we can see at x values, but here we can see, so these are after converting this normal distribution to standardized normal distribution, this x-axis becomes z. So always 0 represent the mean, right? That's the thing you should keep in your mind. The set score simply tell you how many standard deviations a specific value x is away from the middle, right? So this is 0 mean if x value, any x value here, it's mean it's deviate one standard deviation, right? One standard deviation from the mean. This translates any messy business problem into clean, searchable numbers. Now, whenever a question approaches you, you can't blindly don't blindly try to answer the questions. Always draw the normal distribution curve in your hand. Never calculate blindly. Sketch the curve and shade the area you need to find. So whenever ask probability for the any distribution, that is any normal distribution questions, so you have to draw this, and then keep remember, right? Always remember total area under the curve equal to 1, and the symmetric one left side 50, this is right side 50% or 0.5, left side 0.5. Never forget this. The area from 0 to minus 1.61, yeah, minus 1.61 is exactly same as plus 1.61. Say for example, if you find the area here, say 0.4, the same area you can find here, because these two values are equal. Two values. The area 0 to 1 minus 6. This is 0, no? This is 0. Always this is 0. This is minus 1.61. This is plus 1.61. The area from 0 to 161 here, this area is exactly same to 0 to 1.61, this area, because of symmetry in nature. And the rule is here 0.5. Because total area is 1, right? Total area is 1. The exact half to the left side. This is left side and this is the right side. Half. The center of always 0.5, right? So any value or any area to the right side from the 0 is exactly 0.5. And any value from 0 to left side also 0.5. So you have to keep remember in your mind. Now let us see some scenarios. Finding the area between two positive points. Right? Yeah, this is the question. Yeah. Find the area under the standard normal curve for each of the following cases. Here, the area between z, this is plus 2.15 and z 1.24. We should find the area, right? Now, how do we calculate? So this is the normal curve, no? This is the standardized normal curve. This is always 0. It's a mean. This is a mu, no? Mu. It's a mean x bar, or sometimes we put mu. And the question is the area between plus 2.15 to 1.24. Here we have to find the area. How do we find? How do we find this area? Using the table. So the table is given, no? The table is given. The table shows the area under a curve. Yeah, how do we find? We keep recall, right? Recall the rules here, the 3 rules. Here, symmetry and 0.5, left and right. Area under the curve 1. Right, now, in the table, let's look at the table here, the normal distribution table. This table shows you show only the area between 0 to z value. For example, in this case, assume z equal 1.5. It's mean, right, here we see 1.5. Here is 1.5 in the table. Here 1.5 is here, right? 1.5 and 1.50 is 0. So this is 0, 1.50. Then it shows 0.4332 area, 0.4332. It's mean the area between 0 to z 1.5, this area equal 0.4332, right? And my dear students, can you tell me how do we calculate this area? This green area, how to calculate?
Subtract from 0.5.
Very good. Here we know that left side from the 0, this 0.5, and total of this area here 0 to the right infinitive, right, equal 0.5. And we know that this area equal 0.432, and we know that total area 0.5, and it is very easy to calculate this area. How? We know that total area 0.5 and this area equal 0.4332. Therefore the balance will be area under this curve. Area means probability. Remember, area equal to probability, since it's a normal curve. That's a rule. Keep in your mind. Now, according to the question, the question, they ask us to calculate the area between here, area between 1.24 and 2.15. So we directly, by using the table, we can directly find this value in the table. So what we can do is, first, we know the area this toward this from 0 to z to the right. We know that the total area 0.5. That's we know, right? That's one rule. And in the table, we can see area of this. We can find the area of this. Oh, right. And or we can find the area from 0 to this value. There are two options we have, right? We have two options here. First, using the table, we find the total area, right? Total area of 0 to 0 to 2.15, right? First, number one, calculate the area 0 to 2.15. So, what is the area? Yeah, 2.15. 2 this is 2, here 2.15. Where is 5? Here. Then right. This is the area 0.4842. Now we can calculate the area 0 to 1.24. Here 1.24. This is 1.4, 2. No? Yes. 24, right? 1.24. 1.24. Where is 4? Right. This is 1.24. 3925. Now we can calculate easily, right? The total area, right? Say 0 to, so this area, right? This area, this, and this area is this. Then what is the value of this area? How we calculate? How we can find? How we can find? Simply we deduct, right? Simply we deduct. We name this area as A. So A represent, for example, A represent this green area. A represent this one. A represent these areas. And B represent this area. This is B. Right? For example, this is B. Now we need which area? Now we want this area. Right? This area. So what we can do is we can directly deduct from area. This is B. This is A minus B. And A minus B equal, this is C. Right? First answer. Yeah. 0.4842 minus 0.3925 equal Right, the area equal 0.1917. 0.17, right? Okay, this is the answer. Right, here you can see the answer. 0.917. It's mean 9.17 percentage. In other words, the probability between, right, so z value 1.24 to 2.15 is 9.17. Now here, see, that's what it's explained here. First, step 1, look up the area from, in the table, look up the area from 0 to 125. So that is 4842. Second step, find the area from 0 to 124. That is 0.3925, and we subtract from this area to this area, and we can get the area between this rate. And the second scenario, crossing the center events. So earlier we look at the values, all of them are right side to the 0. Now one portion to the right side, another portion to the left side. See the question first. Area, find the area between z minus 1.61, z 1.84. Look at here, this is always, this is z equals 0. This is 0. And here this is minus always left to the 0. Say minus 1.61 and plus 1.84. So we need to find the area. We need to find the area. That is the area of the curve. In the table, it gives always the positive value, not negative value. But remember, due to the symmetric nature, right? Due to the symmetric nature, if you find the area for positive value, that is same for the negative value, right? So keep in your mind. That's the clue. Here, now we will find the area of this. Say we name them A, and this is B. So what is the area of A? Say look at 1.84 in the table. 1.84. This is 1.84. I think here. This is 1.84. This is 4671. And B minus 1.61. Minus 1.61. So as I told you earlier, the area under the curve plus equal to minus 1.61. 1.61. This one. 4463. So this is B. Right? This is B. Now we need total area. So therefore, so what we can do, we can add this together. We will get the total area. What's the total area? Yeah. Point 4671 plus 0.4463 equal 9134. 9134. It's mean 91.34% of the area lies between these two range. here 9.9134, 91.34% of the area is here, right? And here, scenario 3, finding the extreme tail. So these are tails. These are tails. Never touch the tails. Here, look at the question. Question is here. Find the area to the right of Z. So in the normal curve, this is 0 always. This is right side. This is left side. And now they are asking us to find the area to the right of Z. Say here, Z, one Z here. That value is 2.16 Z value. And they ask us to find the area here to the right side. This is Z, this is Z value. To the right, what's the area? That's the question. I repeat again. Yeah, this is a normal curve. They're asking us to find the area to Z to the right side of Z 2.15. Yeah. This is Z 2.16 to the right. So here we need to find this area. Say A. We want to find the area A. But in the table, we can see only these areas. We can find, when you see the table, if you locate Z 2.16, the table show you this area. You see the table? Remember, there are many different type of tables. You have to choose the correct table. Otherwise, right, you may in trouble. Otherwise, you have to understand what exactly the table show you. Right. Now, this is a table. Right, the table give this area. Now we want to find this. So what we can do, we know that the total area from Z0 to the right is equal 0.5. And we can find the area in the table, this. So that is what we can find 2.16. This is 2.16. Somewhere here. Sorry, 2.16 is this. This is 2.16 here. 2.16. That is what? 4846. So this is 4846. 0.4x46. Total area, we know that 0.5. So the balance area A equal what? Simply 0.5 minus 0.4846. It's equal 0.154. It's mean the area, this area equal 1.54%. For probability 1.54. So that is one. Another case, yeah, another question, next question. Area to the left of Z 1.96. So first we have to plot, we have to draw, we have to sketch. Here to sketch here. This is 0 Z, and to the 1.92 plus or minus. This is plus, right? Remember, this is plus, not minus. So it should be to the right side. 1.92. But here to the left of Z. So this is a Z. This is Z. And to the left. So we need to find the area, all of this. So in the table, we can see only this area. We can see only this area. So we know that by theory, this area from 0 to the left, it is equal to 0.5. And we can easily find this area in the, from using the table 1.92. Yeah, 1.92. 1.9. This is 1.92. So 4726. 4726. So we know that this 0.5 and this area equal. This is here how much? 97.926 means 97.26% this area, right? And without table, is it possible? Is it possible to find the area without table? Is it possible? Are there any ways? Are there any other ways to find the values? Yeah, it's given, right? It's confirmed 1.54 earlier we found, and 97.26, right? Any other shortcuts other than the formula? If we use calculator, we can find without the help of the table, we can use the scientific calculator to find the area probability. So you can in the calculator we can find this stated area, and so there are many. I will explain you here. For example, we want to find the area. Say, for example, we are going to find the area probability of 0. Z equal, right? Z equal 1.25. 1.25. By looking at the table, can you tell me what's the area? By looking at the table, tell me. Tell me what is the area? 1.25. This is 1.2. Yeah, 25. Right. This is 3494. 3944. Right. Now, by using the calculator, we can find this. For that, first we have to change the mode to statistic. So statistics 3, and we use one sample. Right. Now we can see the mode is statistic mode, and here shift stat. Right. Shift stat. You can see distribution, and you can see the distribution. That function is on student 5. Now you can see P, Q, R, T. This table, right? This table here, this represented by Q, right? Q, normal standard deviation, standard normal distribution. 0 to Z is represented by Q, right? Here, I press 2. 2. Then I want to find the Z 1.25 equal 39, right? 39435. See, you see here 3939435. So almost 3944. Right. Now let's see what is the probability of the Z on say 0.25. What's the probability? What's the area under the curve? T 0.25. 0.25. Yes.
0.098.
988. Very good. Right. Now let's 0.09. Sorry. 0.25. You see? Same answer. 0.9887. It is 4 decimals. So it is accurate. Calculator is very accurate. So this is rounded for 4 decimals. So, right. So in this way, we can use the calculator. And you see here, right, this question. Look at this question. We found the answer here. We found the answer is what? The answer for this 9726. Now let's see. So we did in 2 steps. First we calculate, we know this 0.5, and then we calculate this area and we add this together. Then we found 97.26. Now I check the answer without doing type 5. Right now this is to the left side, no, that is P 1.92. What's the answer? Answer 97.25. Right? Got the same answer or not? Yeah. 9726. But calculator, we got 97257. So it's rounded. And see this one, this question. Where is it? If we want to find right, this one here, this one, the point is given, right, to the right, not actually this question. Let's see the question. Yes, area to the right Z 2.16. My dear students, this image is wrong, right? This is wrong image. This is wrong. This is wrong, right? It should be here. Because Z value is plus, but here depicted in negative, right? So be careful on that. Be careful. So this is not this one. No? All right, sorry, right, that's fine. This one, right, this one, right. This is correct, right? This is correct. No issue. This is fine. No issue. And here, 2.16. What's the question? Yes, here. Area to the right of Z 2.16. 2.16. How we calculated? How we calculate it? First, in the table, we find this area, right? And then deducted from 0.5. Right? We deducted this area and we found this area. And without doing any calculation, we can use directly apply the calculator 5 P Q R to the right. So is right, this is 3. Now I can write 2.16. 2.16. You see, what is that? Here, what's the value? 0.0153. Right? But we did in 2 steps because this is a different table. P Z to the left, Q 0 to Z, R Z to the right. Right? Very careful. So this is how we use calculator to find out the probability. So that if we have calculator, you don't need to bring table. But that always not true. For this kind of calculation, we can use scientific this model calculator. Right? This model is fine. For reverse, so this calculator does not have function. Right. Now reverse mean this here, reverse engineering. Reverse engineering mean probability back to 0, Z score. Earlier we discussed what? We find the probability from Z to probability. So that's what we did. Sometimes they give us probability. They will give us probabilities, mean they give us area under the curve. Using that area, right, we have to find what is the Z score. This is the mechanism applied for the university admissions. Z score is a cutout marks. Instead of looking up Z value on the edge of the table to find the area inside, we find the area inside the table to look up the Z value on the edge. So normally, what they are emphasizing is, normally we bring a Z value, say Z equal 2.1, Z equal 2.1, 2.12, for example. So in that instances, we trace here 2.12, right, 2.12, right, and trace the probability. That's what we did. But now we have to find a value somewhere. For example, 4114. For example, 0.4114. What's the probability? What's the Z score? What is the Z? What is the Z of what the Z value of this probability from 0 to Z? What? So we have to trace. Where is 14114? Right, somewhere here. Somewhere here. Then what is the Z score? 1.35. So this is probability and this is Z score, Z value. So that's what that kind of things we will discuss. Let's see here. Find the Z when area under the standard normal curve is given as follows. Area to the left, let's write very careful. Area to the left of Z 0.0874. So we have to draw. The curve. We have to sketch sketch, and we know that this is always 0, and here plus, here minus. And what we have to plot, where is it? 0 point. So plus. So here 0.0, right? So sorry, we have to find the z. We have to find the z. Here 0.0874 to the left. To the left, right? I made mistake. This is not z, so I guess 0 plus or minus, so that's wrong, right? We know it's a probability, no, probability always positive. Sorry for that. Area, right? Area represent 0.08 mean 8.74 percentage to the left. To the left. So we know that all this area 0.5, this is 0.5, but this is very tiny area, tiny, very small area to the left, right? Here surely not here, right? So for example, if we put, if we mark, if we guess said here, what's the probability? So it consider all area, right? All area mean here 0.5 plus this area, it's more than 0.5. So we can guess that the z value not right side of the 0. So it should be here less than 0.5, somewhere here, right? It should be somewhere here. And the probability is here, this value, right? We have to find this value, this area. This area is what? 0.0874. And we need to find what is the t, oh sorry, what's the z, what's the z score. We know that in our table, right, we have table that shows this area, only this area, but we want this area. So what we can do is, first we have to find this area, right? We have to find this area. So how we can do this? How we can find this area? How? In the table we can trace. First we have to find the area. First we have to find the area, so that the total is 5, no? Total 0.5. So this total area 2.5, and we need to find the area given by the table. So that is 0.0874 equal, right, 4126. 4126, 0.4126 here, this area, right? This area from this area equal 0.4126. It is given. This area 0.0874. Now we can trace in the table 4126. 4126, right here, or approximately here. So what's the value? The z could be 1.36. 1.36. It could be this z is 1.36 minus 1.36. Why? How do I know this minus value? Because it is left to the 0, left to 0. So therefore should be minus 1.36. Let us check the answer. Yes, yeah. The table needs the area next to 0. Subtract from the half, 0.5 minus 0.874. So this is 4.26. The area, this one. 0126, this area, and we can find this area in the table that shows that Z value is 1.36. Since it's left to the 0, we can put minus. Clear? Is it clear?
Yes, sir.
Okay, good. Now, the second one, area to the right side, area to the right of Z. The thing is very careful, look at carefully. It is more than 0.5, more than 50%. We can write this 0.7846, 78. So they are tell very clearly the Z value, the area, and this is 0. We know that this is 0.5 and this is 0.5. So area to the right. So any value from here, right, it's below 0.5. And if the value 0, if Z equals 0 to the right, this is 0.5. So therefore, definitely the Z should be here. Then only it covers more than pi, right? More than pi. Here, we have to find this value Z. So it's straightforward. The total area is 78.46. Then we can deduct this 50%. Then the remaining part is 28.46 or 0.2846. So the area, this area, right? This we have to find this area because the table only shows this area, no, 0 to Z. So this area equal 0.2846. 2846. Now we'll trace 2846. 28, sorry, not here. 2846. This is very close, you know. 2846. 2846. It's closer. So what is that? 0.79. 0.79. Right. Yeah. You see, subtract the non-left. So this is non-left, 0.5. And we don't know this Z. Then we get 2.46, and if we trace from the table, we can find that this is minus 0.79, right? Because it's fold here, left to the 0. Now let's see the area between minus Z and plus Z, that is 86.25%. So it combination of, right, plus or minus. Here it's the table, right? We sketch it. This is 0. Then they tell us area between minus Z and plus Z. We don't know what's the Z value, but it is symmetric. If we, for example, if we found Z equal plus Z 1.2, this side minus Z also 1.2, right? So that is like, it's look like this. Area between Z minus Z to plus Z. So total area 86.25. Then we know that this is symmetric. So therefore, this portion exactly equal to this portion. Left side equal to right side. Right side equal to left side. So if we divide by 2, then we can get one side. Here it's 4, 3, 1, 2, 5. Right? 43.125. So it's equal to what? 0.43125. Let's see. 43125. 43125. Right? 4325. Right? It's somewhere here. Right? Somewhere here. What's the value? 1.49. 1.49 will be the Z value. Plus, let's see the answer. Is 1.49. Right? Set equal. So this is 1.49. This is 1.49. So summary, the business statistic exams cheat sheets, so the summary. So we can convert any x value to z value. Once they give us the x value and mean, the standard deviation. The core properties you should remember: mean, median, mode. Both of them are equal at the peak. Total area equal to 1. Infinitive tails never touch x-axis. These tails never touch this x-axis. And remember, this is 0.5 and this is 0.5 and any value. So this is z. So this is z. This is left to the z. This side right to the z. And symmetry at the whole area. For example, if 1.5 here, the area, same area we can find, minus 1.5 here. Right? Right. So I will share the recording. You can, I will not repeat, you can share. So you can watch from the video recording. All right. Any questions?